Hello and welcome to our presentation on a functional Smith chart for Brown Hall. My name is Ryan McGill and I will be talking about the project overview.
This is slide 2.
So the whole gist of our project is to create a functional Smith chart that was added during the Davidson Pavilion reconstruction addition to Brown Hall. So in that addition, what they did was they created a full-scale Smith chart that is about 5 feet in diameter. However, it is unusable since we do not have a compass nor straight edge large enough to facilitate using it. So what we are trying to produce is an augmented reality setup so that students are able to actually do EMAG problems on the board without having to have a large compass or straight edge.
Slide 3.
So in short, what we're trying to do is use sensors coupled with a camera input and do some sort of image processing or so back-end processing to create a setup where that you can actually learn how to do these EMAG functions without having to do anything but put stuff on the board.
Slide 4.
My name is William Dover. The main objectives that we wanted for our sensors is that we wanted to maintain a high level of interactivity for the students. This will help them learn the Smith chart better and keep that memory long term so that they'll do better on tests. We also wanted it to be easy for them to understand and use. We wanted them to be able to walk up to the board and start working on it with minimal learning and required to use it. We also wanted an accuracy of around 1 inch. That way we get accurate results whenever they use it. And we wanted it to be reliable and maintainable over the long term so that students can keep it up and keep it working while we're not here.
Slide 5.
My name is Philip Champion. I'm going to be talking about what we have done as the sensor team. So we came up with a few different ideas for how to take input in. And so a couple of the first ones were using an Xbox Connect sensor and also using motion capture. We decided not to use those because of the infrared interference and scattering that can occur that could give us very wrong readings. So what we decided to do is use LiDAR, and what LiDAR allows us to do is have them magnetically mounted on the board. As you can see, this is a test mount right here. And then it also allows for us to be able to stand in front of the board, which image processing solutions would not be able to use.
Slide 6.
So I'm Rebecca Thomas, and I'll be talking about the sensor team's going forward path. So our next goals are to create a portable mounting apparatus for the projector that we plan to use to project the straight lines and circles onto the Smith chart. And along with that, we'll create a mount for the LiDAR as well as shown in the last slide. We also need to integrate sensors with the GUI team and create some sort of calibration to make sure that the projector and the LiDAR are both reading correctly. We will also need to implement the LiDAR, possibly with other tools like computer vision, to create a fully functional board that allows students to interact with the Smith chart.
Slide 7.
Hey, my name is Alex Kaler. I'll be talking about the graphical user interface objectives. So we figured out that what you usually do when you do problems on a Smith chart is you use a compass and a straight edge, and also a pencil. And so we want to implement a compass and a straight edge. Those are the two basic units of a Smith chart. And then we'll use the projector as the actual kind of pencil part. We'll draw circles and draw things, probably not like this, but draw different things on it just to help show the user what they're doing and what they've done. We also we're going to have to interface with the LiDAR information and somehow provide that to the projector and get kind of a feedback system going there. We also want people to use it. We want it to be really easy for people to just walk up, fool around with it, just make it easy for people to use. So.
Slide 8.
Hey, my name's Mandy Fields. I've been on the GUI team, and we've been researching ways to interface with the projector and what kind of projector we're going to use. Since the sensor team has wanted to use a LiDAR sensor and possibly a Raspberry Pi to do the processing, that's given us a little more information, and we can do more research on that. And we have to know how to calibrate the system. So one way would be similar to how active boards are calibrated with different, like 5 different points on the board where you touch it with a pen. And possible programming languages are MATLAB. We thought about using MATLAB if we were going to be doing more Smith chart, shunt stub calculations and stuff, but we don't really know how to read user input in real time with that. So we might use Python or C# or C or Java. We'll be doing more research on that.
Slide 9.
Well, currently our path forward is finding a way to properly implement all these requirements into just an acceptable GBY format. So as I stated beforehand, ways of doing so, we're looking at MATLAB, Java, but what we'd like to do is make this thing easy to use as possible. So we really like to use it just on a Raspberry Pi. What's likely going to happen is we're going to have to find a way to use the laptop as well. So it's kind of going to cut in because we also have to make an acceptable GUI, and maybe like make it look like PowerPoint, something like that, and also feed in live data and output it into a projector. So that's kind of hard to do with just a Raspberry Pi. It's actually really hard to do without a Raspberry Pi. So figuring out a way, or what way to work it best, is our main goal. That's it.
Cool.